What's up, guys? Mr. Garcia here. For your first little online lesson away from me, we'll be talking about a thing called a focus and directrix. So, this is just the building blocks of a parabola. I'm kind of proud of this, not gonna lie. You should focus on a positive directrix for your life. I'll let that sink in a little bit. But that is our discussion today. So hopefully you'll be able to discuss the relationship between the focus, directrix, and the graph of the parabola. Um, Derive the equation of a parabola with the horizontal directrix. We'll talk more about derivation a little bit. And then hopefully just this is the main part. Write the equation of a parabola that's opening vertically. Notice I was very specific to say vertically. Next Tuesday, we'll talk about what it means to be a horizontal parabola. So, first, a parabola. You may have known, if you didn't, parabola, you always think of it as this little opening up and down, kind of very bad parabola right there, but that's all you think of when you think of the word parabola. Well, geometrically, parabolas are defined in terms of a point called the focus and a line called the directrix. And so the geometric definition is a parabola is a set of all points that are equidistant. And so let me highlight this that are equidistant from a given point called the focus and a given line called the directrix. So that word equidistant, that's going to be important for us because that's also be something we'll later on know as the p-value. But basically, that is how we form a parabola. So we're actually going to bring in a little special guest to help us understand what is a parabola. So let me toss it to my special guest here. Why, thank you there, Mr. Garcia. Well, for y'all folks don't know me, my name is David Crockett. You may know me from famous things like in 7th grade Texas history where we learned about the Alamo. And, oh, God bless my soul. Love that place to death. Literally. So, I am just deeply infatuated with mathematics, and in fact, I was discussing the focus and directrix with my pal David Bowie. And not the musician, by the way. So, what is a focus and directrix? So, here's what I'm going to do. Here's what I'm going to do for you folks. Here's what I'm going to do. Here's what I'm going to do. I'm going to take this piece of patty paper, just a piece of regular patty paper, and I'm going to draw a line right on the bottom. Use my good old dandy ruler. This contraption is just so strange, isn't it? I had to get my good old friend Miss Garcia to mail it into me with a pigeon carrier. Man, whew, technology nowadays. Whew. So that's all I did. Just drew a line at the very bottom there. Now, this is going to be my directrix here, okay? Okay. So all I'm going to do next is just draw one dot. Doesn't matter where. I'm just going to pick it just somewhere above. Boom. Look at that beautiful dot there. So here's the thing now. I'm going to try to evenly space out some tick marks on my directrix. And ticks, not like the little things, those little rascals there in the wilderness, but just little marks all around my directrix. And here's the beautiful thing about mathematics. If I am not equidistant in all those tick marks, it's totally fine. It's mathematics. It's actually going to work out wonderful. Wonderful. What a wonderful word. So here's what I'm going to do next. I'm going to take each of those individual tick marks and I'm going to fold my patty paper such that the tick mark is overlapping the dot. And I'm just going to make a good old little crease there. And there's rinse and repeat. Rinse and repeat, which should be doing down, folks, because of that good old corona. Now, next little tick mark. Fold, rinse and repeat, and what is that? David Bowie. Oh, thank you so much. David Bowie actually gave me a completed one to save me some time from this video from being 18 minutes long. So, what we did here is we took each of these individual tick marks and we folded it on top of this circle, this little dot that we made. So it's kind of hard to see. So let me trace it with this good old orange. Fun fact, I got this color orange from an actual orange in the wilderness. Yes, I know. We're a very big wilderness, folks. And for some reason, my accent is going all over the place. But if I did a little tracing there on the crease, and hey, what is that? That looks like a parabola, doesn't it? Here is the cool thing about this parabola. If I was to take a line, here we go, we'll do this here. I'll put that line in blue. That distance at the top right there is the same distance to right there. So this line at the bottom is called our directrix. And this dot right there is called the focus. So I can do that crazy thing here with any part of this parabola. That accent went all over the place there. And I still have the same distance. So you do that an infinite, I never knew that word, an infinite amount of times, and we got ourselves a parabola. Well, folks, I got to get going. That good old Santa Ana scheming up something big. Although that's not possible because I died in the Alamo. However, I will be avenged. Watch out, Mexico. My accent went away. I'm going to throw it back to Miss Garcia. See you later, folks. What a special guest that we just had. Thank you, Davey. I really appreciate you coming out to help me talk about focus and directrix. So you there in your home, just give a little round of applause to Davey. I think he did a swell job. Hopefully we don't hear from him again. If we do, well, we do. So here, let's look at this. What is our directrix? So Davey showed us with that little patty paper, the directrix and the focus, they make up our parabola. So in this here, I tried to draw our little directrix, and this point F right here is the focus. And so when I did my little tick marks, I was making all of these different points. So P, Q, and so on and so forth. I made all these points such that it now became a parabola. And so here is the cool thing that we need to know and focus on. This distance right here, let me see if I can draw on this without it messing up. I may not be able to. This distance right here, if you remember these terms from geometry, these two distances are the same length. These two as well. And that's good news because that's what makes a parabola symmetrical. This part right there that I'm kind of like making slashes on, that's called my value of P. So you're going to hear me say this like 18 million times. The value of P is the distance from the vertex to the focus, or the or the vertex to the directrix. Again, I'll say it one more time. The value of P is your distance from your vertex to your focus, or it's a distance from your vertex to your directrix. It doesn't matter because they are the same numbers. It all depends on what they gave you in the question. So again, the parabola is always going to open in the direction of the focus and away from the directrix. Now, it says when a directrix is a horizontal line, the parabola is going to open up or down. It all depends on the focus. We're going to only talk about horizontal line for directrix today. We'll talk later about what happens when it's a vertical line for a directrix. So every point on the parabola is equidistant from the focus and the directrix. This is important because if we don't have equidistant, we don't have a parabola. I always kind of use the term like the parabola hugs the focus. The parabola hugs the focus. That point focus is going to be on the inside of the parabola. It's like giving a hug, which is kind of like illegal nowadays. So this is the derivation of it. Basically, I'm about to give you a formula. It's kind of like, wait, what? How'd you get that formula? This is how I got it. My concern right now during this little summer semester is not for us to completely understand this formula. It's not. Although it is nice, it is kind of handy. However, for the purpose of this summer semester, I just won't discuss this derivation. If you want me to, please ask me later. But this is basically using the distance formula you learned in geometry. And which, hey, geometry coming back, isn't it? So all this stuff to give us this equation. Y equals 1 over 4p parentheses x minus h, and this should have a squared right there. I apologize. So that should have a square. I'm going to try to draw in, but I probably won't be able to because my computer is not being the best. So that should be a squared. Perfect. I can't draw. Let me try to my mouse. Amazing. That's not too bad. So the equation of a parabola in vertex form is y equals 1 over 4p x minus h squared plus k, where p is the distance, again, that p, from the vertex to the focus, or the vertex to the directrix. And hey, the vertex, we discussed that on Tuesday, didn't we? The vertex is your point h comma k. Now, it all depends on your focus. And when p is bigger than 0, the parabola opens up. When p is less than 0, your parabola is opening down. So biggest thing here, this looks the same as our vertex form, except that this equation, that 1 over 4p, it is now being replaced by our value of a. And so here, an example that we're going to work through. And here's what I recommend you write down this example. I'm going to show you 3 examples, I believe. So I want you to write these examples down. We're going to write an equation of a parabola that has a focus of 0, 2, and a directrix given by y equals negative 2. So to write this equation, we must identify the value of p and our vertex. If we find those two, we're good, we're set, we'll use our equation. So again, the equation is y equals 1 over 4p x minus h squared plus k. So let's try to work this one out. So we have a focus of 0, 2, and a directrix of y equals negative 2. So let's just plot that on our little graph here. So the focus is a point. So let's go to our point and let's go 0, 2. Now let's go to our directrix. So as you notice on that patty paper and on everything else we did, our directrix is a line. Now I'm not going to draw a solid line just so I don't get it confused with my actual parabola. I'm going to draw a dotted line. Again, your teacher may want a solid line. It all depends. There's different things in mathematics. So we have a focus of 0, 2 and a directrix at y equals negative 2. Now, we need to find our vertex. That's the biggest thing. And remember, the vertex is an equidistant from our focus and our directrix. So this distance right here, from your focus to your directrix, how many is that? It looks like it's 4 units. You go 4 units down or up, whatever way you're counting, to get to our thing. So your vertex has to be equal distance from your focus and your directrix, which means it must be straight in the middle of it. So that means your vertex, and I'll pick a different color. Let's do this color. Your vertex must be at that point right there. Wait, why is it at that point? Look here. It is 2 units away from your focus, and it's 2 units away from your directrix. So this is saying here, my vertex, it's going to be at that point 0, 0. The reason why? It's equidistant from your focus and equidistant from your directrix. So now, when we have our equation here, so y equals 1 over 4p x minus h squared plus k, let's plug in what we know. So as a reminder of Tuesday, our vertex is the point h comma k. So I won't, oh, that's weird. Here, that's cool. I won't plug in, that's awesome, isn't it? Perfect. I won't plug in my value of p just yet. Let's plug in our value of h. So h is the x value of my vertex. K is the y value of my vertex. And then we can simplify this part, can't we? So I'm going to work that out to the side just so you see what I'm about to do here. So x minus 0 squared. Well, what is x minus 0? I mean, it's just x. You're subtracting nothing from x, so that means it's just x. And x squared, well, I mean, that's just x squared. That's a bad 2. I know it is. So that means here, when we write our equation y equals 1 over 4p, this inside part now becomes solely x squared. And it says plus 0, but we don't need to carry on to plus 0 because, well, you're adding nothing. So now we have y equals 1 over 4p x squared, and, well, we're not done. We need to fill in our value of p. And again, the value of p is going to be that distance from your vertex to your focus or your vertex to your directrix. Again, it doesn't matter. And in this case, our value of p must be the value of 2. So we'll say, one more time, come on, perfect. Y equals 1 over 4 times 2 x squared. So this is nice. 1 over 4 times 2, well, that's just 8. We'll actually have a fraction as our final answer, which is fine. It's still a number. Y equals 1 over 8x squared. Now, if you have a graphing calculator, you can try to graph this, and I'm going to pick a different color. Let's do this green. So this is what it's going to look like. Remember, the focus is being hugged by the parabola. So it's on the inside of my parabola. Again, it's not be perfect, but my concern really is the equation. So this opens up. That means this value is positive. If that value, that circle, that 1/8, if it was negative, then it would open down. So that's one way I know it. Second way I know that it must open up is my focus. Let me get my laser pointer out. My focus always is on the inside of my parabola. The parabola is going to open the opposite of my directrix. Since my directrix is down here, my parabola is not going to open down. It's going to open up. So 2 different ways to know how I knew how to graph it. 1, the focus. Your parabola will always hug the focus. And 2, look at this value of a, that value in front of your equation. If that's a positive, it's opening up. If it's a negative, it's opening down. Wait, why is it opening down if it's a negative? Take a second. It's negative. That means it's a reflection across the x-axis. Those transformations we discussed on Tuesday. If it's negative, that's a reflection across the x. All right, so we're going to do another example. I want you to try this one by yourself. I know it's a new thing, so pause the video and try this one by yourself. Pause it, pause it, pause it. Perfect. You probably spent 20 seconds or 18 minutes. I don't know, but let's try this one out. Write the equation of parabola whose directrix is y equals 6 and the focus is the point 40. So let's just draw our directrix first. So y equals 6. So 1, 2, 3, 4, 5. Oh, yikes. 3, 4, 5, 6. Perfect. That is very crooked, but we get the gist. The focus is the point 40. So let's draw the point 40. 1, 2, 3, 4. And we plotted it. So our goal here is to write our equation. Now, first, we need to figure out what is our value of p, and then from there, we can figure out our vertex. Now, this distance is going to help us find our value of p. So what is that distance first? Well, count off from that y value to there, and it looks like it's 6. So the distance from your focus to your directrix is 6. That means the distance from your focus to your vertex must be half of that. You got to find the midway point. So let's pick this color. That's not too bad. So 3 points right there. 3 points, 3 values. So this, I went up 3. And right here as well, I went up 3. So that means that point right there must be my vertex. And notice the vertex is kind of like on the same axis of symmetry, throw back to that vocab from Tuesday, as the focus. So your focus and vertex are on the same axis of symmetry. It needs to be because it's symmetrical. Cool. So that being said, let's find out. First, let me actually write my vertex is the point. Looks like that's 1, 2, 3, 4. 1, 2, 3. The point 4, comma 3. That's my vertex 4, comma 3. And again, our equation for a horizontal directrix is going to be, let me see if it'll let me write, y equals 1 over 4p x minus h squared plus k. Y equals 1 over 4p x minus h squared plus k. Let's plug in what we know. And in this case, I'm going to go ahead and plug in my value of p. I'll do it all in one step just because we know that now. So my value of p is 3. Again, that value of p is the distance from our focus to our vertex, or from our vertex to our directrix. Doesn't matter. Up to you. Cool. Let's plug in what we know. Perfect. Amazing. Y equals 1 over 4 times p, which is 3. X minus my h value, my vertex, which is 4, plus the y value, my vertex, which is 3. Now, I know last time we discussed how to multiply x minus 4 squared. However, I'm just going to leave it like that because it's still in vertex form. This question doesn't tell me to move it to standard form, does it? So I'm just going to leave it like that. But we can simplify that first part of the fraction, can't we? So y equals, perfect, amazing, y equals 1 over 12 x minus 4 squared plus 3. Now, if you rush this, you will miss this one because we're still not done. This actually is not our final equation. 2 reasons why. Remember, and if it helps, that's why I have this graph here. So let me get a different color and let me actually draw this graph. I knew it was going to open up like that because the focus is on the inside of our parabola. Again, the focus is on the inside of our parabola. Directrix is on the other side. This actually opens down. But with our equation right here, it's actually saying it opens up. So we need to fix our equation. Our equation needs to have a negative with that 1 over 12. That looks terrible, I know, sorry. So the reason why, again, we need a negative because our parabola actually opens down. If we have a parabola that's opening down, that means there is a reflection across the x-axis, which means that value of a, it must be negative. So my actual equation needs to be y equals negative 1 over 12 x minus 4 squared plus 3. So recap what we did here. First, we plotted the focus and directrix. Cool. So that was at this point right here and this point right here. Next, we found our vertex by finding our value of p. So this whole thing here was 6. That means the value of p is going to be that 6 cut in half. That means here must be our vertex. That's at the point 4, comma 3. Next step, plug in what you know. You know the vertex. You know the value of p. So plug in all this good old stuff into our equation that we got. So p was 3, so 4 times 3. H is the x value of vertex, so that's x minus 4. And y is the k value of your vertex, so that was 3. So, and then the final step is, hey, let me just make sure this is correct. So I plotted my problem and I was like, oh, wait, I need to have a negative out front because this parabola is actually opening down. This is a common mistake you will see people make. They'll do all this work, which is a great and amazing, but they forget their negative. That focus is important. It changes everything. So, one more example. I want you again, pause the video. If you didn't last time, try it this time. Again, it's a matter of trying. Pause the video, pause the video. Perfect. Hey, welcome back. I know you probably waited a long time. You tried it by yourself, totally. You totally didn't cheat, whatever. Write the equation parabola Directrix is -5. So 1, 2, 3, 4, 5. And the focus is at -5, -9. I don't know if I put enough space here. 1, 2, 3, 4, 5, 6, 7, 8. Yikes, I didn't, but that's fine. 1, 2, 3, 4, 5. That should be at the point -5, -9. This won't be perfect. I apologize, but we'll get there. So here I have a focus of -5, -9, and a directrix of y equals -5. First goal, let's find our value of p so we can find our vertex. So let's do this a different color. This distance from your focus to directrix, what is that distance? 1, 2, oh gosh, it's lagging on me. Looks like it's a distance of 4. There's distance of 4 from that directrix and focus. So the value of p is that total distance cut in half. We'll pick, yeah, it's 2. That's 2. That's a 2 actually. Surprisingly, that's a 2. I know it doesn't look like it, but it is. Okay, that means to find our vertex, travel that value of 2. And it must be on the same axis of symmetry as our focus. Again, the same axis of symmetry as our focus. So I went 2 down from the directrix, or I went 2 up from the focus. But that point right there, let me see if I can write on it like this. I can, perfect. Perfect. My vertex is going to be the value of -5, comma, 1, 2, 3, 4, 5, 6, 7. -5, -7 will be my vertex. And my value of p is going to be 2. If it helps you right now, just so you won't forget, is this going to open up or down? I'll give you a second. It will open down. The reason why, my parabola is going to hug my focus. My parabola is going to hug my focus, so the focus has to be on the inside of my parabola. So if it helps you, you can go ahead and say this p should be negative. Because when you plug it in, well, let's do it right now actually. So y equals 1 over 4p x minus h squared plus k. So y equals 1 over 4 times -2 x minus, okay, well, what's my x value on my vertex? Oh, it's -5. Careful here. X minus -5. My k value is the y of my vertex, so that is -7. So y equals 1 over 4 times -2 is -8. So I'll put the 8 there and the negative out front. X minus -5 is the same thing as x plus 5. And then that's just -7. So this equation, if you graph that in your calculator, you should get the same thing that we did there on the side. I want to try to fix my technology errors next time so we don't go back and forth a lot. And I'll assign a homework assignment over this so you can run practice. Now, if I was to try to do this next one, x equals -5 is my directrix. 1, 2, 3, 4, 5. I think that's at 4. 3. That's wrong, but I'm not doing this one either way. And then at the point 5, -8. So 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. If I was to try to do this one, there's multiple reasons why I can't do this just yet. I will be able to do this in a bit, especially on Tuesday. I will. But for right now, I don't know what to do. Because if you notice, I said that your vertex is going to open, sorry, your focus is going to be on the inside of your parabola. So if I try to find this good old vertex here, so this distance is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be at a decimal, which is fine. I'm just going to take a guess. Let's say it's right there. This parabola is going to be a horizontal parabola, which is new. You haven't seen this yet. And so my equation is not going to be the equation we've been using. That is the goal of Tuesday's class. We'll discuss horizontal parabolas. In the meantime, you have a homework assignment over this stuff for vertical parabolas. If you have any questions over it, please send me a message on Canvas or just send me an email. Any one of those two works. You have my email address there in the syllabus. If not, enjoy your weekend. I hope Davy Crockett never comes back. Maybe someone else will come back. Not Davy Crockett, because I'm a little more creative than that. And I'm sorry for the accent. It was starting to sound like George Bush there for a second. If you have any questions, make sure to send me an inbox message on Canvas or just an email. If not, you guys have a great weekend. It's going to be raining, I know, but whatever. Have a great weekend, guys.